Okay, geometries, we're going to go ahead and give you a key for quiz A. Multiple choice, circle the best answer. Number 1, name 3 points that are collinear. Collinear means all in the same line. Our only option are these 3 points right there. So we're going to go ahead and choose A, because that's our choice that has T and Q and R. Number 2, ray RP is represented by what sketch? We have to find a picture that has an initial point of R that travels through P, so our answer here is C. Number 3, plot the points. We understand our XY coordinates. We start graphing from the origin, and our X values show us how far left or right to go, and our Y values show how far up or down to go. So for point A, I need to travel -6, up 1, 2, 3, 4, which puts A right here. B is over -1 and up 1. C is over +3 and up 1. So when I plot my points, my next direction is to sketch angle ABC. So B has to be the vertex. So when I sketch that angle, that is an obtuse angle. Number 4 says, using the points above, sketch angle BCA. So when we look here at angle BCA, I know here, oops, I lost my B. Let me get that back. When we find BCA, C is now my vertex, and A is my angle, and that is an acute angle. So carefully look back at where you struggled and see what questions you might have for next class. All right, be sure to show your work and write your final answer in the blank provided. Oh, draw a smiley face next to your name on page 1 if you have read those directions. So many of you read the directions, which I was so excited to see. Great job. All right. Y is a point in the interior of angle AOB. So we'll go ahead and draw an angle, and we'll call it AOB. And I know that Y is a point in the interior, which means that when I draw ray OY, it looks like that. When I name my adjacent angles, I'm going to go ahead and make sure that I start off with the angle sign. Adjacent angles are the angles who share a common side. So that's going to be angle AOY and angle YOB. All right, let E be between F and G. Sketch and use the segment addition postulate. So we'll go ahead and draw what that sketch looks like. We'll draw a line segment, and we'll say that E is between F and G. Now here's the thing, nobody said that E was the midpoint, so all I know here is the distance from F to G is 56, and I know that the distance from F to E is 2x plus 18, and I know the distance from E to G is 6x plus 6. So my equation that I end up using is going to be 2x plus 18, which is my distance from F to E, plus 6x plus 6, which is my distance from E to G, that's going to be equal to 56. So when I go ahead and I solve my equation, I'm going to combine like terms. 8x plus 24 is equal to 56. I'm going to subtract 24 from each side, which gives me 8x is equal to 32. I'm going to divide each side by 8, and I get a value of 4 for x. When I need to figure out what the distance from E to G is, I'm going to take that 4 and plug it in for x. So I know that 6 times 4 plus 6 is going to be the distance from E to G. So that's going to give me 24 plus 6, or 30. So I know the distance from E to G is 30 units. Okay, let's take a look at 7. The correct notation for the segment, it says it's a segment, so it's got to have the line on it from W through point X. That means it's including each of those points, W and X. When I talk about the length of the segment, this represents the distance from Y to Z, and that's just going to be YZ. All right, let's take a look at 8. On segment MQ, so we'll go ahead and draw segment MQ. Here's M, and we'll make this Q. Let's go ahead and build what this segment says. N is between M and O. O is between N and P is between, wow, let's go ahead and take this one step at a time. N is between M and O. So we'll go ahead and we'll draw N and we'll draw O. O is between N and P. And I know P is between O and Q. Okay, that makes sense. The distance from M to Q is going to be 30. The distance from M to N is 5. The distance from MN to MO is also going to be equal. All right, so we have MN is 5. And then the distance from M to N is the same as the distance from N to O. So if MN and NO have the same length, that means that they are both worth 5. If the distance from O to P is the same as the distance from P to Q, I know that they are the same, but I don't know what they are. So when I go to write an equation that represents all of this information, I know that 2x from this x and this x plus 10 from this 5 and that 5 are going to be equal to 30. Subtract 10 from each side, divide by 2. So I know my x has a value of 10. Now when I go to find the distance from N to P, because this is 10 and this is 10, I know that from N to P is going to be 5 plus 10, so that's going to be worth 15. And we can put units in here. We don't know inches, centimeters, so we can fill that in. All right, let's take a look at next one. Find a point coplanar with B and C and G. Here's B, here's C, and here's G up front. So when we go ahead and we look at the plane that contains them, we need to think about this one that we can't see that cuts diagonally from back to front of the box, which means it's H that we need. All right, let's go on to the next page. Points X, Y, and Z are non-coplanar. That means they don't exist in the same plane. What is the intersection of planes WXY and WYZ? So this is definitely a hard problem to conceptualize. So we'll go ahead and we'll draw, and we know we have non-coplanar planes that are intersecting. So maybe what we might want to do is go ahead and draw what we've seen already a bunch of times in class and what we made with our little pieces of paper. And let's talk about what is common between these two planes. And we can erase this to see that blue plane and that green plane. So W, X, Y, and Z, let's talk about the first plane, W, X, and Y. So when we'll talk about that, we'll make that the blue plane. So we'll make W be here, and we'll go ahead and put X here and Y here. So when we talk about our second plane, our green plane, notice I need to reuse W, so my order is not going to work because I need W in the green plane also. So what I'm going to do is I'm going to move W down here, and I'm going to see if I can switch this around. So now W is in both the green plane and the blue plane. Guess what? I need to reuse Y. So I'm going to go ahead and erase this Y because I need Y to also be down here in the green plane. X is fine where he is, and then I can draw Z somewhere else. So when I start talking about what is my intersection, this line here is going to be my intersection because W and Y are both parts of both the blue and the green plane. That was definitely a tricky problem and might have taken you a little time to sketch and figure out. All right, this next one, measure of angle 2 is 82 degrees, so we'll write that in there. Measure of angle 4 is 58 degrees. Because I know that they create a straight angle, I know that 82 plus 58 is going to be subtracted from 180 to get the measure of angle 3. So when I go ahead and I say, okay, 82 plus 58, that's going to give me 140, which means that the measure of angle 3 has to be 40 degrees. When I say 180 minus 140 is equal to 40, measure of angle 3 is 40 degrees. Make sure you remember your degree symbol. So when I want to know the measure of angle 5, since I have 58 degrees here, I know that the measure of angle 5 plus 58 is going to be 180. So I need to subtract 58 from 180, and that's going to give me the measure of angle 5 is 122 degrees. All right. In the figure shown, the measure of angle AED is 102 degrees. AED is 102 degrees, which means by vertical angles, so is this one. So when I need to figure out what is true, let's go ahead and say here, when I look at letter A, BEC and CED are adjacent angles. That is true, and I'm looking for something that's false. AEB and DEC are vertical angles. That is true, but remember, I'm looking for something that's false. The measure of angle BEC is 68 degrees. That is not true. I've already decided that they are vertical angles that are congruent. So that's going to be my answer because, again, it's false. All right, so when we go ahead and we solve for x, These two are a linear pair, which makes them supplementary. So my equation, 3x plus 23 of my one angle, and my 3x plus 139, which is my second angle, they are going to have a sum of 180. When I go ahead and solve that equation, I end up combining like terms, and I have 6x plus 162 is equal to 180. So 6x is equal to 18, which has x equal to 3. When we look at this one here, number 14, these two are vertical angles. So because they are vertical angles, I know that they have the same measure. So my equation, 4x plus 19 is equal to 5x plus 14. So when I subtract 4x from each side, and I subtract 14 from each side, I get x is equal to 5. All right, last page. Name an angle supplementary to COB. So we'll go ahead and COB is the angle that I want. Then the easiest thing to do here is to just check out its linear pair, which is going to be here, angle EOB. Maybe instead you wrote it as angle BOE. Either of those were fine. Next up, find x and y. So we need to take this into two parts. That's okay. We'll go ahead and say 2x plus 40 has to equal 110 because these two angles are vertical. So we we can go ahead and say subtract 40 from each side. Shift this back to where it belongs. There we go. My sensitive board keeps dancing around on me. So we'll subtract 40 from each side, and we get 2x is equal to 70. Divide by 2. Things keep flying away on me. Divide each side by 2, and I get x is equal to 35. So now I can use that in supplementary angles if I wanted to do any of this math involving my x value that I just solved for. Or I could go ahead and put my vertical angles equal to each other. You have a couple different choices when it comes to how you want to solve for y. I'm going to go ahead and set 5y plus 10 equal to 6y minus 2, because to me adding 2 to each side and subtracting y from each side was super fast, so y has a value of 12. Okay, A is supplementary to angle B, so that means that if I'm going to go ahead and call this A and this B, because they're supplementary, I know that A plus B is going to be 180. If the measure of angle B is twice the measure of angle A, I can go ahead and substitute this in for B. So when I solve that, I can say A plus 2A is equal to 180. 3A is equal to 180. So A is going to be equal to 60. So the measure of angle A is 60 degrees. Coming down here, if I need to figure out here this measure of angle HJL, we can call this x. And I know that x plus 40 has to equal 90 degrees, and I know that because of that symbol there. Those are complementary angles. So I know that x is going to be equal to 50 degrees, the measure of angle HJL, 50 degrees. Lastly, briefly describe one thing you learned about the history of Euclidean geometry. Your answers were great for this. Somebody told me it was really old. Somebody told me that Euclid was the father of geometry. You also told me that he did a lot of organizing. You also told me he took other people's ideas. You told me that it was very specific. You told me that we paid a lot of attention to details. And you talked about postulates and givens. In my mind, all those things, you did a great job. All right. So 20 minutes was what it took me to go ahead through and explain this math to you. Hopefully you better understand. Please come to class with questions so that Mr. Logan and I can help you. All right. Good job, everybody.